record and add my voice to it. So the first question is demanding that you state Archimedes principle. Then the II part said derive an expression for the upthrust on a body of weight W and density sigma. Okay, this symbol is what we are calling as sigma. This symbol is a Greek letter. The name is sigma. So the body has a weight of W and has a density sigma when it is immersed in a liquid of density rho. So the density of the liquid within which the body is immersed is rho. Okay, I mean this symbol. It's also another Greek symbol, and that's how we pronounce it. Rho. RHO. So we are to derive an expression for the upthrust. Okay, when an object of weight W and of density sigma is immersed completely within a liquid of density rho. The B question says that, okay, so that's the AII. Okay, so let's look at AI, then we move on to look at what we are to do for the B question. So let me invite Adjoa Asante. Adjoa Asante, state Archimedes principle for us. State Archimedes principle. Adjoa, we are waiting. Oh, Adjoa is not around. Okay, then let me call Elikem. Adjoa, are you there?
Yes, please.
Okay, state Archimedes principle.
Yes. When a body is fully or partially immersed in fluid, the abstract, which is equal to the weight of the fluid, the abstract is equal to the weight of the fluid displaced by the body.
So come again.
When a body is fully or partially immersed in fluid,
yes,
it's an abstract which is equal to the weight of fluid displaced by the body.
The body experiences an upthrust or an upward force, which is equal to the weight of fluid displaced by the body. That's very good of you. So that is it. When a body is fully or partially immersed in fluid, it experiences an upthrust, which is equal to the weight of fluid displaced. That is Archimedes' principle. Okay, so let's straight move to question A. Hello.
Please, can you repeat the Archimedes principle? I want to write it.
When a body is fully or partially immersed in fluid, when a body is fully or partially immersed in fluid, the body experiences an upthrust or upward force, which is equal to the weight of fluid displaced. You can add by the body. The body experiences an upward force or upthrust, which is equal to the weight of fluid displaced. That is Archimedes' principle. Okay. All right. Then B, AII. So derive an expression for the upthrust on a body of weight W and density sigma when it is immersed in a liquid of density rho. So let's take the details as given in the question concerning the body. So weight of body is W. Density of body is sigma. The body has a density of sigma. Please design the letter well. Then we are also given the density of the liquid. Density of liquid is given as rho. We are to derive an expression for the upthrust. So the first thing to do is that what is upthrust? Let's represent the upthrust by the letter U. Upthrust is equal to we just stated Archimedes principle. And under Archimedes principle, we are saying that when a body is fully or partially immersed in fluid, it experiences an upthrust, which is equal to the weight of fluid displaced. So upthrust is equal to weight of fluid. Okay, here we are told it is immersed in the liquid. So weight of liquid displaced. Okay, so if U is equal to weight of liquid displaced, what is weight? Weight can be determined by mass of the liquid displaced, m subscript of the liquid times gravity. Class, I hope you are with me. Are you with me? Okay.
Yes.
Yes, please.
All right. So mass of liquid displaced times gravity. I also want to express mass in terms of density and volume. So the same upthrust is also equal to the density of the liquid, which was given to me as rho, times volume of the liquid, okay, times gravity. So straight away, I've substituted the density of the liquid because mass is density of liquid times volume of liquid displaced. So I've made use of the density of the liquid rho given to me in the question. Are we okay here?
No, please.
You see, upthrust is equal to mass of liquid displaced times gravity. Okay. And I want to express mass of liquid displaced in terms of density and volume. We know density is mass over volume. So if I have mass and I want to express it in terms of density and volume, then I make mass the subject. If you make mass the subject, you have mass is equal to density times volume. So from here, it means that the mass of liquid displaced can also be expressed in terms of the density of the liquid times the volume of the liquid displaced. And that is what I've done here. Are we okay?
Yes, please.
Good. All right. So it means that to get the expression for the upthrust, this is given in the question. That is rho. Gravity is constant. I will need the volume of the liquid displaced in order to find an expression for the upthrust. So the part of this thing I need to obtain is the volume of liquid displaced by the body. Once I get the volume of the liquid displaced, I'll substitute it in the end. I can then have an expression for the upthrust on the body. Are we okay? So the only bone of contention here is to determine the volume of liquid displaced. If I get the volume of liquid displaced, I substitute here, multiply, and I can obtain an expression for the upthrust. Okay. Now, how do we obtain the volume of liquid displaced? How do we get an expression for the volume of liquid displaced? Please, any contribution? How do we get the volume of liquid displaced by the body? Any contribution from any one of you? Please, let's be snappy. Okay, Yaba.
Area, please, the volume of the liquid displaced is the same as the volume of the object of the body. So,
On what condition are you saying this? Why? Yaba is saying that the volume of the liquid displaced will be equal to the volume of the object. But on what condition is she saying this?
Archimedes principle.
Okay. Or because, yes, she's right. And she can say so because the question is saying that the body is immersed in the liquid. So once the body is completely immersed in the liquid, the volume of the liquid displaced is equal to the volume of the object. Class, are we okay?
Yes.
So
Yes.
volume of liquid displaced will be equal to the volume of the object. And the reason is that because the object is completely immersed in the liquid. So if the volume of liquid displaced will be equal to the volume of the object, it means that once we get the volume of the object, we have the volume of the liquid displaced. Is that what you are saying?
Yes, please.
Then I put it to you. How do we get the volume of the object, Yaba?
And we have the density of the object. We need a density of the object and then the mass of the object to find their volume.
So how do we do it?
The density of the body is sigma. And then you use the weight of the body to find the mass.
Good. Thank you so much for the contribution. So you see, we have the density of the object, which is sigma. We also have the weight of the object, which is W. Okay, we can use this to find the volume. What is weight? Weight is mass times acceleration due to gravity. Let's express, and this is the of the object, so please, is the of the object. Let us express mass in terms of density and volume. Can somebody do that for me? I want us to express the mass of the object in terms of density and the volume. Yes. Yeah. Yeah,
The mass is density times volume.
so the mass is density times volume. So we have sigma given to us as the density of the body times volume of the object, which we don't know, times gravity. Please, the underline is equal to the mass of the object. Are we okay? The underline is equal to the mass of the object because we are only expressing mass in terms of density and volume. Are we okay? Class, are we fine?
No, please.
The weight of the object is equal to the mass of the object. Let me come again. Weight of the object. Let me write O, subscript O to denote object. Even though what I was given, there's no O, but I'm doing that to distinguish it from the liquid. So WO is equal to mass of the object times gravity. Okay, and mass of the object is also equal to the density of the object, which was given to us as sigma times the volume of the object. Please, are we okay?
Yes, please.
Go. So let's now substitute this into this formula. When you substitute, you have done weight of the object equal to density of the object times the volume of the object times gravity. I hope that's okay. Let's make volume of the object the subject. Yes, Amma, what will be the expression for the volume of the object from here? Oh, Amma. Okay, Kirsten, are you there?
Say,
Help me out here. Let's make volume of the object the subject from here.
volume of the object will be equal to weight over density times gravity. Sorry, weight divided by density times gravity.
Good. So VO, thank you so much. It means from here we have to divide through by sigma times g at both sides of the equation because we are making this the subject. So this and this will cancel, this and this will cancel. Therefore, volume of the object will be equal to weight times density times gravity. Okay. And once we have the volume of the object, this is equal to the volume of the object is equal to, yes, quick one. The volume of the object will be equal to
Volume of fluid displaced.
exactly the volume of liquid displaced. Okay, so look at it. To get the upthrust, we needed volume of the liquid displaced. Now we've succeeded in obtaining that. So what do we do? What do we do from here? Yes, what do we do? Quick one. What do we do? Yes, go ahead.
We substitute the weight over density times gravity into the
Abstract.
equation for after.
Exactly. Okay. I want to, please, if you are writing, quickly do so because I want to adjust the screen to the other side of the board. So if you are writing, please hurry up.
Please, I don't understand.
Where? Which part? Which part?
From the density of the object.
We were given the density of the object to be sigma, this symbol. This symbol is the density of the object. The question gave it to us. So sigma is the density of the object. Rho is the density of the liquid, okay, of the liquid. W is the weight of the body or of the object. Okay, so these are information given to us from the question. Okay, are you okay? Okay, I'm sure you are done copying. I want to redirect it. Can I do so?
Yes, please.
Okay. Good. So upthrust U is equal to density of liquid times volume of liquid displaced times gravity. Okay, we have VL. So let's substitute. When we do the substitution, we have upthrust to be equal to rho times W over sigma G times G. And gravity would cancel out so that the upthrust is equal to rho W over G. So this will be the expression for the upthrust. For the upthrust. So we haven't introduced anything new. We are only using all that the question gave us. Okay, substituting our final answer. Rho is the density of the liquid. W is the weight of the object. Sigma is the density of the object. So we haven't introduced anything new into it. I hope that's okay with all of you.
Yes, please.
So this is, in fact, WASI 2021, the first paper was cancelled. And what I just gave you, the question on the board, is one of the questions from the cancelled paper. Let me say two of the questions from the cancelled paper. WASI 2021. Okay, so let's move on to the second question. I hope you are done writing this.
Yes,
That's okay. The second question, that is B says that a solid weighs 237.5 grams in air and 12.5 grams when it is totally immersed in a liquid of density 1.5 grams per cm cube. Calculate I, the density of the solid. Then I, fraction of the solid submerged in a liquid of density 1.19. Okay, so let's extract the information from the question. One, we are given it weighs the object weighs 237.5 grams in air, and this is actually mass in air. The mass of the object in air is 237.5 grams. Then, and 12.5 grams when it is totally immersed in a liquid of density. So the mass of the object in liquid is equal to 12.5 grams. What is the density of the liquid? The density of the liquid, rho of liquid, is equal to 1.5 grams per centimeter cube. We are to first calculate the density of the solid. Density of the solid. Now, the first question demands that we find the density of the solid. So rho of the solid obviously must be equal to mass of the solid over volume of the solid. Please, are we okay? Are we okay? And this
Yes, please.
mass of the solid must be the mass in air. So it means that we have the mass of the solid, which is 237.5. Okay, But we will need the volume of the solid to find I, which is the density of the solid. Class, how do we help me to find the mass of the solid? How do we find it? Yes, ideas. As many.
Sir, please, I can't see the board.
Really? Oh,
Yes, please.
what the situation? Is it blurry? What is the nature? Because it's clear.
I can't see what is written on the board.
Really? Oh, please, is it a general problem to all of you?
No,
No.
please.
Then, as well, please rejoin. Okay, disconnect and then rejoin. Let's see. Okay. So all that we need to find the density of the solid is this. Sorry, I said is the volume of the solid. We just need this because we have the mass of the solid. The mass of the solid is the mass in air, which is 237.5. So if we could get the volume of the solid, bingo, we are good to go. Yeah, so how do we get that? Yaba. Yaba, go ahead.
Please, the volume of the solid is equal to the volume.
Is equal to
The volume of the solid when it's equal to the volume when it is immersed in water.
So yeah, it's saying that the volume of the solid will be equal to the volume of the liquid displayed. But yeah, it's true because we were told from the question that the body is totally immersed, totally immersed. That's what I've underlined. So Yaba is saying if we manage to get the volume of the liquid displaced, it will be equal to the volume of the solid. Please, do we all agree with her? Do we agree?
Yes, please.
So the question is, how do we also determine the volume of the liquid displaced? Yes, I want you to also contribute a bit before I come in. All right. So let's share ideas. How do we determine the volume